Okay, so back again. We are now on section 2.2. My suggestion, I'll scroll it a little bit slower so you can pause at good places, but the first page of this is literally just notes, stuff you technically already have because it's just the forms, and then just a couple things that I want to make sure that you emphasize in your notes. We've been saying it before, but it bears repeating constantly because it's something that you're going to be told to write and recognize all the time. Okay, so arithmetic behaves like linear and geometric behave like exponential. We already know this, but without, connecting the dots. Okay, so again, I'll scroll slowly so you can pause, copy down whatever it is you need. We've already got, both of these forms. And again, slope-intercept and point-slope form. We've already talked about how those are pretty much the same thing as far as when you substitute in. Okay. And then the geometric. I've actually never used the point form of an exponential. I've actually never seen it used in anything. We normally just use the basics, a times b to the x. Now we do use the one where you have like minus h plus k, where you're actually like shifting that that zero value, what would normally be on the y-axis. But I've actually never seen one written like that. So I'm assuming it would be something fairly close to the minus h plus k form. Okay, so I do, again, we need to keep straining and just make sure you keep this in your brain, okay? And we've said it more times than I even want to count. Over equal length input value intervals. That is an entire phrase that you need to like memorize, right? When you have a linear function or an arithmetic sequence, the output values change at a constant rate. Okay, for exponentials or geometric over equal length input value intervals, the output values change proportionately, meaning that you are multiplying, whether it's by a fraction or a whole number, you are multiplying by something. Okay, so if you have 2 points, you can write these. So we've already practiced that in 2.1 as far as writing arithmetic and writing geometric. So now we have a little bit more that we can actually do. Okay, so we said this before, given a set of output values, given a table, given a graph, you should be able to tell, again, looking at your output values, first, whether it's arithmetic or geometric. You should be able to look at it and see whether you are adding or multiplying by looking at the values. Because if you're adding, then they would be going up by only, so much every single time. If it's multiplying, they're going to keep getting bigger and bigger and bigger, right? So our job, again, is to figure out if it's arithmetic, geometric, or neither. So we're just going to look at our first either differences or first divisions. Okay, I'm looking at this one, and this is definitely not being like multiplied by anything. I can tell. Okay, so again, we work backwards. 5 minus 7 is negative 2. 3 minus 5 is negative 2. 1 minus 3 is negative 2. Negative 1 minus 1 is negative 2. Yay! It is arithmetic. It has a common difference of negative 2. Oh, and since, I was stressing it so much, we really, really should always look at our x values first and make sure that they are equal intervals, right? To make sure. So 0, 3, 6, 9, 12, we're good. 1, 2, 3, 4, 5, good. That one goes up by 2. That one goes up by 5. So all of my x values are those specifically equal length input values, right? It doesn't mean they have to be successive 1, 2, 3, 4, 5. It just means there has to be the exact same amount of space between each one to be able to prove this be able to prove that this is, or by using our first differences rather. And no, my apologies, your common difference is actually not negative 2. It's that your common difference is constant. We would actually have to find the values in between to figure out what the common difference is. My apologies. So the common difference is constant. It's probably negative 2/3, being that you're going up 3 on the x and down 2 on the y. So, but again, we'd have to fill out all the rest of it, arithmetic, just to check. But we can say that the common difference is constant, right? Constant rate. Okay, so again, I know for a fact, just looking at this, that's going up 1, up 3, up 5, up 7. This is definitely not going to be arithmetic, right? So I'm not going up by the same amount. I could at least still check to see if it was geometric, just to see if it's being divided correctly. But 1 over 0 kind of stops me because I know that's going to be a does not exist. And then 4 over 1 is 4, and then 9 over 4, no, it's a different fraction, and then 16 over 9. So I know for a fact that it's not arithmetic. It's not going up by the same amount every time. And in this case, it's not geometric at all. In fact, if you recognize it, it's quadratic. Because if you took your first differences, then your second, they would match. But it doesn't matter in this case because all we care about is that what do you want to call it? Let's see, the outputs do not change at a constant rate. Or proportionally. If you want to be the actual like full-on statement, like if they ask you to explain why something is, like on an open response question, that's what you're looking for. The outputs do not change at a constant rate or proportionally. Okay, so, and of course we, throw in there over equal length intervals, right? Over equal length input intervals. Okay, so the next one, again, up by 1, up by 2, up by 4, up by, okay, so this is definitely not arithmetic, is not being added for anything. So let's check if our ratios are the same. So again, 2 divided by 1, 4 divided by 2, 8 divided by 4, 16 divided by 8. Yes, this is geometric. Your common ratio is proportional. We don't know what the common ratio is because these are not going by ones as far as your x values, but your common ratio is proportional, or you could say your output values are proportional with, again, equal length input intervals. Always, 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 as far as that goes. Okay, so the next one. So again, I can tell that this is not going to be arithmetic because, again, it's not adding something equal every single time, no matter what the x is. Okay, so, but I can, again, do the division. So 40 over 80, 20 over 40, 10 over 20, 5 over 10. Okay, so same thing. This is geometric. Output values change proportionally. Just like I said, there's another way to write it, but these are like how you would want to explain over, if you're talking about an open response question, right? This is how you'd be expected to explain why over equal length input intervals. And that's the best way you can actually explain it. And they asked linear or exponential, so we could just say, we already know as far as sequences, geometric and exponential go hand in hand. As far as just connecting the dots or not connecting the dots. And if it's arithmetic, then it is linear. Okay, so. All right, so based on what we talked about yesterday, we're going to do a couple of practice problems.